Okay, so before the video starts, I have completed my coursework on absolute uncertainties. You have my notes, Cambridge past paper questions, and my worked solutions. You can also gain access to my A2 A-level physics courseworks on Patreon. So, with that being said, let's get cracking with the video, starting with a visual stimulated explanation.
In the early 2000s, using the European Space Agency's Hipparcos satellite, scientists discovered Methuselah, a star located 200 light-years away from Earth. However, Methuselah was no ordinary star, as it baffled astrophysicists around the world because after dating its age, it was found to be older than the universe itself. For context, the universe is 13.7 billion years old, whilst Methuselah was 14.4 billion, making it 0.7 billion years older. However, Methuselah's age was a discrepancy, an anomaly arising from the usage of outdated instruments and uncertainties, absolute uncertainties to be more precise. After further refining our measurements, astronomers were able to crack down the age to just 12 billion years, and that's the power of uncertainties. So with that being said, let's now dive into the wonders of this topic.
Okay, so absolute uncertainties. I think the best way to explain how this works is by working some basic questions first. So to start with, we are going to be working with addition and subtraction. So let's just work out the first question. We are provided with two lengths and we are to find their sum as well as the new absolute uncertainty. So let's just calculate that. L1 plus L2 is equal to 3.4 plus 4.3, which gives us 7.7 centimeters. Okay. Now our absolute uncertainty would be L1 plus L2 is 0.2 plus 0.3, which gives us 0.5 centimeter. Hence, therefore, our answer would be L1 plus L2 is equal to 7.7 plus minus 0.5 centimeter. That's your answer. Such a terrible arrow. Okay, so the second question, we have been provided with two masses and we are to find the difference. So let's just find that. M2 minus M1 is equal to 60 minus 50, which gives us 10 kg. And for our absolute uncertainty, we are simply going to be adding both absolute uncertainties just like we did above. So M2 minus M1 is equal to 3 plus 2, which gives us 5 kg. So therefore our answer would be 10 plus minus 5 kg. Good. Now we move on to the second part of our questions, which is multiplication and division. In this question, and we're to find the area, so let's just write the formula here. Area is equal to length times width, and that would be 4 times 6, which gives us 24 centimeter square. And now to find the absolute uncertainty, we simply write delta A 0.1 plus 1, which gives us 1.1 centimeters square. Therefore, our answer would be 24 plus minus 1.1 centimeter square. Good. Now, moving on to the next question, we have a car. A car has traveled a distance of 60 centimeters in 20 seconds, and we are to find the speed. So speed is equal to distance over time taken, which would be 60 over 20, is equal to 3 centimeters second. And to find the absolute uncertainty, we simply add both absolute uncertainties. So delta V is equal to 0.4 plus 0.2 is equal to 0.6 centimeters second, which therefore V is equal to 3 plus minus 0.6, and that's your answer. So now, okay, before we move on to the next section, I want you to remember this. Okay. Whenever you're working with absolute uncertainties, if you need to divide, multiply, add, or subtract, you will always be adding your absolute uncertainties. But if ever you are working with brackets or orders simply means x squared, square root x, or anything around those lines, then you will need to multiply the absolute uncertainties. So this is something you need to know, the laws of exponents. So imagine you have 9 cubed 3. It can also be written as 9 1 over 3. Okay, so this is something you need to learn because you'll be using it in the past paper questions. Let's just get started on the questions that I have here. So we have power. We have to find the square of this power here. So let's just find that. P squared is equal to 34 square is equal to 1156 watt square. And how do we calculate the absolute uncertainty now? Well, we simply take the exponent, which is 2, and multiply it with the absolute uncertainty. So delta P is equal to 2 times 2, which gives us 4. Therefore, P squared is equal to 1156 plus minus 4 watt square. And that is your answer. In the second question, we have magnetic flux density. And we have to find the square root of magnetic flux density. So let's find it. We have square root B is equal to square root 500, which in rounded terms gives us 10 square root 5 Tesla. Okay, so how do you do the absolute uncertainty for a square root? Well, remember the laws of exponents over here. You simply need to find the exponent, which is b to the power of half. And now you take the exponent and you multiply it with the absolute uncertainty. So you should be getting delta square root b is equal to half times 4 is equal to 2 Teslas. Therefore, square root b is equal to 10 square root 5 plus minus 2 Tesla. And that's your answer. Okay, so in the last part we have absolute uncertainty, fractional uncertainty, and percentage uncertainty. So I'm just going to write a measurement followed by its uncertainty. That's quite a lot of uncertainty to say, but okay, we got length is equal to 5 plus minus 1 centimeter. So, as we probably substantiated from the examples we did above, this plus minus 1, that's your absolute uncertainty. Well, what about the fractional uncertainty? Well, I want you to imagine a rod, and the length of this rod is 5 centimeters. And our error would be minus 1 centimeter or plus 1 centimeters. So, what fractional uncertainty wants us to find is what fraction of 5 centimeters is this uncertainty found in. So, we can find this by using the formula delta A over A, where delta A is the absolute uncertainty, which is 1, over, and A is the value or the recording, which is 5. And the answer to this would be 0.2 centimeters. So our fractional uncertainty would be L is equal to 5 plus minus 0.2 centimeters. And that is your fractional uncertainty. Now, what about the percentage uncertainty? Okay, now what about the percentage uncertainty? Well, I'm just going to write the length again. So we have 5 plus minus 1 centimeter. To do the percentage uncertainty, I want you to remember this formula right here. Delta P over P is equal to delta A over A, where P is equal to 100 and delta A over A is your fractional uncertainty. So let's just find your percentage uncertainty. I'm just going to write the formula again. So delta P over P is equal to delta A over A. Delta P over 100 is equal to 1 over 5. Delta P is equal to 1 over 5 times 100 is equal to 20%. Our percentage uncertainty would be L is equal to plus minus 20%, and that is your percentage uncertainty. And with that, we conclude our explanation and move to the past paper questions. So let's start working some past paper questions. Okay, the first question, calculate the absolute uncertainty of length x. So this length here. But the problem here is that we've been given the percentage uncertainty, so how can we do this? Well, delta P over P is equal to delta X over X. Now, the delta X over X is your fractional uncertainty. So, we can find delta X by simply replacing delta X is equal to delta P over P times X, which gives us 5 over 100. Don't forget that P is 100 times 4, and that gives us 0.4. Now we need to find the percentage uncertainty in the calculated value of rho, which is density. Okay, so I've already reworked the formula, making rho the subject of formula. So let's just rewrite it here. Rho is equal to 3m over hx square. Just need to confirm if I wrote it properly. Yes. Okay, so how can we find the percentage uncertainty of rho, given that m, x, and h, all three of them have their own percentage uncertainty? So how do we do this? Well, delta p is equal to delta m plus 2 delta x plus delta h, which gives us 2 plus 2, 5 plus 4, which is equal to 16. Second question done. So we are supposed to find the pressure of the pyramid, so we know that pressure is equal to force over area. Our mass is equal to 19.5 grams, which we need to convert to kg. So it's 0.0195 kg. And x is equal to 4 centimeters, which we need to convert to meters, which is 0.4 meters. Okay, force is equal to the weight of the pyramid because, well, gravity is acting on it, so there is a downward force acting on it, so that's pretty much it. We can calculate weight by using weight is equal to mg, 0.0195 times 9.81. Therefore, P is equal to 0.0195 times 9.81 over 0.04 times 0.04 is equal to 11956, which can be rounded off to 120 pascals. Okay, let's move on to the second question. Underline all units that are SI base units, so that would be degrees Celsius and kilograms, because, well, degrees Celsius and kilograms, kg. In this question, we are to calculate the percentage uncertainty of the value of E. E, where are you? Okay, so this is E. I'm just going to rewrite the formula here, km over t square. Okay, the percentage uncertainty of E, km over t square. So we know that the percentage uncertainty would be p delta E over E, but all the values of these are already in percentage uncertainty, so we can simply add delta P is equal to 2.1 delta P is equal to delta K plus delta M plus 2 delta T, because the exponent of T is 2, so we need to multiply T by 2. Okay, that would be 2.1 plus 0.6 plus 2.15, and that would give us 5.7. Done. Okay, so in the final question, we need to find the value of E, and we can find that by simply writing delta E over E is equal to delta P over P, making delta E the subject formula. We get delta P over P times E. Now, delta E is equal to over 100 times E, which is which is this. So 8.245 times 10 power 9 gives us 4.7 times 10 power 8, which can be rounded off to 5 times 10 power 8, and that gives us 8.2. We simply rounded off this value here, and now this gives us 0.5, because power 9, so 0.5 times 10 power 9. Okay, so let's move on to the next question. Question number 2. What do we need to do? Calculate the acceleration of freefall G. Okay, G is equal to 4 pi square times 1.50 divided by 2.48 square, which gives us 9.63, which is two very significant figures. So 9.63. Good. And now we are supposed to find the percentage uncertainty. So delta P over P. No, I just realized that they have given us the absolute uncertainty. Well, the uncertainties here are in fact percentage uncertainty, so we don't need to pass through this formula here. We simply need to write delta P is equal to delta L plus 2 delta T. 2 delta T because, well, in the formula, T is raised to the power of 2. So we need to multiply by the exponent, so 2 multiplied by delta T. Okay. That gives us 2 plus 2 multiplied by 3, which is 8. Our percentage uncertainty is 8. We are to calculate the absolute uncertainty of the value of G. So we now use the formula delta P over P is equal to delta A over A. Making delta A the subject formula is equal to delta P over P times A. Okay, so delta A is equal to 8 over 100 times 9.63. This is A. So here it is, and that should be giving us 0.77, which can be rounded off to 0.8. 0.8, that's your answer. And okay, we are now supposed to find the percentage uncertainty of the value E. Okay, we have been given the value of L and the percentage uncertainty. We've also been given the value of I and the absolute uncertainty. So we need to convert I into percentage uncertainty. I'm just going to do that over here. Delta P over P is equal to delta I over I. So delta P is equal to delta I over I times 100. Delta P is equal to 0.2 over 0.5 times 100, which gives us delta P is equal to 4. So your percentage uncertainty for I is 4. I is equal to 0.5 plus minus 4%. Okay, so delta P for E is going to be 2 delta I plus delta L. 2 delta I because I is raised to the power of 2. So we need to multiply the exponent, which is 2, to our absolute uncertainty or percentage uncertainty in this case. So delta P. Okay, so 2 times 4 plus delta L, which is 5. And that should be giving us 13. Good. Done.